So I will want now to welcome the first speaker. He's Robel Kitaba, and without further ado, he will talk a little bit about himself. We don't want to do the long introductions. We want to redeem time. And I would want also to ask if it is possible that if you see that a speaker has covered an aspect, in the interest of redeeming time, you can pass on and then we can proceed. So can we have Robel's presentation on the screen, please? As he's talking about himself. A round of applause.
Thank you. Okay, I've been asked to make my presentation quick, so I'll try to go quickly. Good morning, guys. My name is Robel. I'm a network engineer by trade. So I have around 17 years of experience here in Ethiopia, in Europe, and in the US, focusing mostly on global backbone and the internet age, particularly on the CDN network operation. I worked at Amazon and Meta on the global backbone, implementing, designing, and operating their global infrastructure. And also in Ethiopia, before my relocation, I worked at ZTE, deploying the then new network called the NGN, which I believe is still here. So the goals of this talk is to give you guys a little bit about the basic of what the internet is. Depending on who you ask, different people can give you what internet is for them. But we are here engineers, and as an engineers, we need to go a little bit technical. So I'll try to cover that and then probably provide some insight on the current interconnections status here in Ethiopia, and provide also possible opportunities for future improvements. Okay, so the internet for most people looks like this. They would have a PC or a mobile, and they will try to connect to a website. It's oblivious for them where that is, but some picture in this case, like a funny cat picture. So this is what they see. This is what people would say internet. They might have some notion of that website is somewhere outside. In the Ethiopian case, it's outside the country. So when something happens, it's like the internet is down, or you would hear in the news that the fiber cable is cut. There are some reasons, right? But for us, for network engineers, this is what we see. So the PC would be usually called a client device. And then the picture hosted somewhere is called the server. And then in between this, there are network devices. These are, fancy name is router, but they are specialized computers to do only route traffic from point A to point B, in this case, from the client to the server. And a group of these devices are called a network. So in the internet, when we say network, just a group of devices that move traffic from one place to another. And then a network, as often is the case, won't have all the destinations. So it have to go to another network to provide you or to deliver the necessary website traffic. So then a group of these networks combined together to collaborate to form what we call internet, which is a fancy name of internetworking, which means one network would work with another to deliver the traffic. In reality, this network interaction happens over a very long distance, usually thousands and thousands of miles. So usually networks would only care about their specific locations or this specific focus area, they would build the necessary infrastructure, and then they would hand off the traffic to the next network at a certain location. And usually it's very expensive to build this interconnections infrastructure, which which I would call a fiber. And there are only a few handful of companies that have a global wide fiber infrastructure. So what usually happens is that there are few facilities that these networks can exist or want to exist. And then if they want to hand over to another network, they would go to these facilities, which we call interconnection hubs, or what we call now IXP, which is the Internet Exchange Points. So these are focused on kind of playing the role of a meeting hub or a meeting location. So a network A would say, hey, where does network B exist? It's in this location. Let me go to this facility, and then I would interconnect with these guys. So these interconnection points are globally available. Even in Addis, there is recently, I heard one pilot as a test. There are about 1,200 internet exchanges in the world, according to PeeringDB data as recently as yesterday. Most of these exchanges or interconnection hubs are locally significant, which means they focus on a specific location in a city or in a country. They don't have that much significance out of that location or a country. Some exchanges, however, are regional significance, which means that people from the region, network from the region would go to this location to interconnect. A very good example in Africa is NAP Africa, which is, I believe, the first exchange points or one of the first in South Africa, and is the biggest, I believe, where the whole Southern Africa networks would go and do peering or interconnect. However, globally, there are further handful or a couple of dozens of interconnection hubs that are globally significant, which means if they go down, a significant part of the internet, the global internet, would be affected. They are very big. They have very big infrastructure available, and there are only few of them as compared to the rest of the world. For example, the London Exchange, the Marseille Exchange. The Marseille Exchange actually serves Africa, Middle East, and South Asia. So it's significant. The London Exchange also serves the whole Europe and Africa to some extent. And then the Northern Virginia Exchange probably serves the whole of North America and Europe as well. So these exchanges interconnect with each other as well. They are very well connected and well run. And people network intentionally go there to find relatively good internet interconnection there. So when we look at the East Africa or IGAD region, it's a little bit not as it should be. There are 12 exchanges, as I counted from PeeringDB. 7, I believe, are in Kenya, and then 1 in each of the rest of the countries. So there are some opportunities here to actually do more of this. And then when we talk about the interconnection types, there are 2 types as a larger umbrella. I'm not going to go in depth of what the different types of the transit and the different type of the peering relationship is. There are subtle differences even within each. But in general, to summarize, a transit is where you pay a network to reach the rest of the internet or anywhere effectively. So in this case, network B will say, you need to pay me some money, and then I'll give you access anywhere in the internet. If you want to go anywhere, I'll give you access, but you have to pay this amount of money. And that is a relationship called transit, or provider and a customer relationship. However, a peering is when two networks identify that there is mutual benefit to exchange traffic between them for free, but only to the destinations for their own network. So in this case, network B will say, let's provide access to each other, which means network A can only access network B, and network B can only access network A through this peering, and you don't have to pay anything. So that is a relationship called peering. There are different subtypes of the peering, but in general, this is how it works. It doesn't give access to the rest of the internet, but to a specific network, and it's usually settlement free. And there are different scenarios where it makes sense to do peering versus transit. As you can imagine, transit relationship requires a lot of money being paid by the customer. So it might make sense to go and do peering. However, it's not always the case. Even if there are peering relationships available, you might want to do transit just because of the availability of the whole internet, right? So the transit providers usually would guarantee that you can reach anywhere in the internet. So that is a very compelling reason. Sometimes it could be a performance. A peering might perform sometimes slightly lower than the transit, just because the transit providers would have a lot of global infrastructure in place. So it might make sense. So it's always a balance. The other aspect is that even if one network does peering, it's not always cost-free. There are always costs associated. These facilities where you go and peer usually would have a membership fee or some kind of space and power fee. And of course, you have to actually get to the interconnection facility, which means that your data center traffic might be, your data center facility might be somewhere, and the interconnection facility might be somewhere else. So you have to actually buy a lease line or fiber to reach there. So there are some costs associated, but in general, relatively speaking, the cost is significantly lower than the transit, and you have to balance when to do that. So when we look at the Ethiopian interconnection status, first is Ethio Telecom, which is the largest network in the country. It doesn't appear to do any peering. According to PeeringDB and some of the BGP routing tables, Ethio Telecom network is solely feasible via transit networks. So which means they go somewhere and buy the transit stations. Usually, I suspect in Djibouti and Sudatel in Sudan, some cable, I believe, in Somalia or in Djibouti, and China Mobile and China Telecom in either Djibouti. So these are public available data. I'm looking from the outside. Maybe things might be different from the Ethio Telecom side of things, but from what we see, they don't do any peering, and they don't have any presence even in the local internet exchange, which I believe was recently forked. So the next one is Safaricom Ethiopia, the second largest network. So when we look at the PeeringDB and some of the BGP routing tables, at first they do look like that they don't do any peering. They don't have any presence in any of the internet exchange. Although I think from what I got some of the information this morning after I prepared that slide, they probably have a presence in the local internet exchange, but they probably might not have updated the PeeringDB. So at first, they might not look like that. However, Safaricom is a subsidiary of Safaricom Ethiopia is a subsidiary of Safaricom Limited, which in Kenya has a versatile peering presence. So my suspicion is that, because it's the same company, or relatively they have a good relationship between the same sister companies, they do local peering between themselves. So it's not going to be fair to just blame them that they don't peer. I suspect that they do peering. However, they also buy transit from Djibouti just because of the proximity to Ethiopia. Kenya adds around 2,000 kilometers to the international traffic paths, while Djibouti is around 700 to 800 kilometers. So it makes sense to buy transit there. So a case study which I tried yesterday and which Dr. David alluded earlier is I wanted to see if I send a traffic between Ethio Telecom and Safaricom, where would it actually land and how the traffic path might look like. So this is the trace route which any one of you can do from your computer locally from this Wi-Fi hotspot, which uses Ethio Telecom. And then the destination is one of the IP range from the Safaricom Ethiopia IP address allocation. So you can see here the blue line is low latency because it's local within the Ethio Telecom infrastructure. However, the next line, which is the yellow one, there is around 18 millisecond jump. And that is the Djibouti Telecom, or the SOM cable, the SOM cable paths, which is the Somalia cable, I believe. So the latency jump is, I assume, is from Addis to wherever the Somalia cable is, possibly in Djibouti. And then, interestingly, the next line you see, the red one, is an international tier 1 provider, Cogent. So Somalia cable hands off the traffic to Cogent, possibly in East Africa, either in Djibouti or in Hargeisa. But then Cogent doesn't have any destinations or have info to reach the Safaricom Ethiopia traffic locally. So it would send it to Marseille. And then it would send it to another Cogent router in Marseille, where that router have an info where to send it to reach Safaricom Telecom, and then it would send it to Kenya, Cogent. And then Cogent, I believe, either peers or there is a transit relationship to Safaricom Limited in Kenya, and then Safaricom Limited would take the rest of the traffic back to Ethiopia. So it adds an unnecessary high latency of 2 milliseconds, where both the source and the destinations are in Addis, which in theory should be around 3 to 4 milliseconds. And this is the reason why peering is important, because sometimes, you, without an awareness or with some reason, you do take traffic unnecessarily long paths when you have the option to actually send it locally, providing high quality, good internet service to your customers. So there is some opportunities here. One important point I want to mention is that maybe doing a peering in this case might not make sense if you don't have any traffic to go between Ethio Telecom and Safaricom. Maybe right now it might be very minimal traffic. So we don't want to have additional cost of getting into an internet exchange and doing peering. But the principle is there that doing a peering locally makes sense for this kind of reasons. So based on my personal view, I can see a few challenges at the moment. One of the main challenges that there are relatively two big networks, Safaricom and Ethio Telecom. Maybe Ethio Telecom is the biggest one. And then there are very few networks that can actually economically make sense to do peering, either because they don't have traffic or they are exclusively home to either Ethio Telecom or Safaricom. So this is the challenge. Even if you have an internet exchange, if the only access to the internet is via Ethio Telecom and Safaricom, it doesn't make sense to do peering unless you have other network paths to provide alternatives. So this is a challenge I would see, although there is an IXP started here, and I hope that we can see more networks to start to recognize that they can do peering. For example, banks can do free peering between them, and then they can have lower cost and more quality. So these are the challenge I see from the network size perspective. The other main one, which I believe we mentioned a few items in the last session yesterday or the day before, is the local content. So there are almost zero local content, I would say. So the whole Ethiopia internet traffic is heavily inbound. I would say significantly inbound, the traffic, which means that the traffic load is coming from outside, and then the users here in the country are the consumers. So there is no source of the traffic here, and this ties into a lot of other issues of does peering make sense if there is no local content, if there is no traffic locally, then how can we create data center, because there is no the commercial sense that is not there. The other slightly lower challenge, I would say, is the lack of engineering expertise and context to do peering. So I focused a little bit about local peering here, but there is the option of regional peering. Our region has at least few exchanges where there are very good peering opportunities. So it might make more sense to actually, and cheaper to actually buy the fiber infrastructure to go to this exchange regionally and peer freely to these global internet companies. So that kind of option requires some engineering context, and I do recognize that there might be some lack there. And of course, when we talk about this, it's relatively high cost at this point of time. The fiber infrastructure, the lease lines might make less sense at the moment, but in the future it might be good. And then the last one is the regulatory framework is at the beginning, so it's very early stage. So a lot of items needs to be encouraged and empowered for the local content or for the peering or for these networks to have like a more fertile ground to improve. So I would say that probably that area is the most challenging because, from my experience, technical stuff is easy to do. We can get a group of engineers into the room and we can probably find a way. However, regulatory and policy frameworks tend to always, create unique challenge. So some opportunities from my personal experience, I would say Ethiopian network can improve, or there are some opportunities to do better. Is our region in East Africa particularly are seeing an IP transit price erosion. So which means that the price to do peering is significantly going higher, or is significantly larger than the price to buy a bandwidth from the actual subsea cables and do regional and global peering. For example, we will have a bunch of subsea cables globally, in East Africa in the coming 2 or 3 years. They are going to land with a massive amount of bandwidth capacity. So, buying a bandwidth from one of these subsea providers and do settlement-free peering somewhere in Europe or in Africa will be cheaper than actually buying transit in Djibouti. So I hope that this is going to go down and down, and then the networks are going to recognize that there is this opportunity that they can make use of that. The other one is the local content, and this one is a tricky one, but still I put it as an opportunity because there are local data centers and local interconnection facilities popping up. However, that also would encourage other companies to form a network and to create their local entities. And with these subsea cables available, I would hope that the global internet companies can have the incentive to actually come to Ethiopia and do local content locally. So as Mr. Dawit mentioned, we have the potential to actually become a hub. For example, relatively speaking, utility electric power is cheaper in Ethiopia than in the rest of Africa. Where the data center main requirement is power, especially in the AI age. And of course, the fiber in connectivity within the country is relatively better. And then once you have the international subsea cable, the final piece will be there to actually provide the incentive for others to do the content hosting and the content generation locally in Ethiopia. So I hope that this too will be an incentive and will be the trigger to do more in the next few years. So in conclusion, I want people to take into memory that the internet is not just a service, or the internet is not just a website. It's actually much more complex, and it involves a complex collaboration between networks. And that collaboration is what makes the internet tick. And these interconnection hubs, the internet exchange, are where the internet actually lives. And that part is an important point, because the decision makers and the policy makers needs to take into account of how to improve based on this. And then how you do the interconnection matter. It matter on the quality, and then maybe on the cost of the whole internet package to your customer. So how to do the interconnection and the peering versus the transit, where to do it, when to do it, that actually have a lot of effect. And I believe the networks take this more into consideration when they design and then when they decide. I hope this is informative. Thank you very much.